Hi class, here's the lecture for week 4, and it's going to be talking about iteration in MATLAB. So iterations is one of the most key strengths of programming in all programming languages, but especially in MATLAB. It allows you to repeat tasks very easily, and there are two forms of iteration, so this is a key concept, and one of these forms we've already been doing, and that's called implicit iteration. And for example, if you use the function sine and you passed in, instead of just one value for x, you passed in an array. What it will be doing is doing a loop to compute each value in that array of sine x. Log space is another example. The semicolon operator, so 1 colon 1 colon 5 would iterate through to create a loop for you. So that's a form of iteration that we've already been doing and you didn't even know it. The other form is explicit iteration, and that's what we'll be talking about in detail today. And I could, for example, do the same thing as linspace by making this an explicit array. So here I've made x with the traditional implicit method using the function linspace, but I can also do a loop, and we'll explain how this loop works. One thing to note, though, is that while explicit loops are really convenient and sometimes they're easier to wrap your head around, MATLAB is actually optimized for us to do implicit loops. So it's much faster to run implicit loops. So there are two types of loops that MATLAB has for explicit iteration. There are for loops, where we know before we run the loop how many times the loop will be indexed, and there are while loops, where we don't know how many times we're going to go through the loop, but once some certain condition is met, we'll stop the loop. So in this lecture, I'll explain both for loops and while loops. So first, let's cover for loops. So the syntax for the for loop is it always begins with for, and it's lowercase for. You'll know you've done it right because it will be blue. That must be followed by a space. The thing that immediately follows the for is the first variable that will count through the loop. So this is called the index. That should be equal to some value, and it should be equal to an array. And what MATLAB will see is that array will give it the index loops, the index steps that it wants to loop through. So the sort of notation on that should be your start value, your step value, and your stop value. So where the start value is the initial value, the step value is the increment, and the stop is where you want to terminate your loop. Within that, you can have any block of code, and just like our branching, for loops always have to have an end statement, so that is mandatory. So here's a block diagram that represents how for loops work in MATLAB, and it might look confusing. There's all these arrows, but once you get used to reading these block diagrams, they're actually quite useful and quite easy to understand. And the traditional way that a for loop runs is when you're above this code and it sees the word for, it will start with whatever start value you've given it and assign that to k, which in this case is our index. So k here we're indexing with, and then it'll check, is k greater than the stop value? If k becomes greater than the stop value, it will exit this for loop and continue on the code. And if not, it keeps stepping through our block of code, and it will increment each time by the step size. So let's see how that would be implemented for an example set of code. So here we have a for loop that I've written. K equals 1, so that's the start at 1, step by 2, and we'll stop at 7. And this is a classic thing that we might want to do, is we might want to build an array within our for loop. So what I've done here is I've taken some variable x that I'm going to create. So x doesn't have to exist prior to executing this for loop. So I am taking x, and in the k, and this is our index, in the k spot of x, I'm going to assign k squared. So when I start this loop, right here we have k equals to 1. It'll ask, is k greater than 7? Of course that's false, and it'll put 1 right here and execute that line of code. And now variable x is created, and since this is the k equals 1, it's going to put 1 in that first array. Then MATLAB, the for loop, will automatically increment. So some other programs like C, you have to do the incrementing. The for loop in MATLAB will automatically increment for you. Notice that I haven't had any code here increment k, but the for loop is actually a function, and MATLAB will increment it for you. So it would add the step size, which we specified as 2. So the next value of k would be 3, and it would check before it runs this next line of code. Is it greater than 7? No, it's not. Now this is something you should be aware of, is that if we're stepping by 2 and I'm indexing right here with k, the next index I pass is 3. So we skipped 2. There's a 0 there. Nothing happens in there because we didn't make anything, but that's okay. It'll just put a 0 there, and it'll keep on stepping through this code until we get to equals 7. Now what is it going to do? Is it going to run through this code? Well, is 7 greater than 7? And of course the answer is false. So it will actually run through this last value of code and we'll get 49. So that is the array we're going to make. It's going to increment k again, and now of course this is true, and it would continue on through our code. So now that we've run a for loop on paper, let's go ahead and see what it looks like in MATLAB. So I've set a breakpoint right at this for function on this script of the code we just did on paper. And what I'm going to do is run. And this is a nice way to debug because it's going to stop right here. So I don't have any variables created because I cleared them all. And k actually doesn't exist yet, neither does x. So what I want to do is step this code, and you see as soon as it executes this for loop, let's take a look at our workspace over here, and we have now that k is equal to 1. That's because k is the start value. This is the first time through the loop, and when I step through this code, now I've just made a variable x. And let me open that up here. So now we can watch our x grow as we make this array. And so in the first index of k, it put k squared. So now it's at the end of the loop, and it would ask, is k greater than 7? And of course that's not true, so it's going to come back to the top of the for loop. Now you can see that k is 3 because we're stepping by 2. If I step through this line of code, you'll see it'll put the 9, and I can continue stepping through, populating this code. So some things to consider for for loops is that you can step by a negative value. So that is legal. The default value, if you don't provide a step size, just like when we do arrays with the colon indexing, is +1. But you may step by negative values. The one thing to be careful there is if you're building an array, of course there is no negative address. There's also no 0 address, so be careful because that would throw an error. Also for step sizes greater than 0, the loop would not execute if the start size is greater than the stop size. So like when we build arrays, we know that we could actually have this case and it would just put the start value in. This actually won't execute if you do a for loop. And for step sizes less than 0, it would not execute if the start is less than the stop. And if it start will actually equal a stop, so say I start from 5 and do semicolon 5, then it would execute only one time. And the one thing you can do is you can do non-negative or non-integer steps. So you can step by 1/2, you can step by 0.25. The problem with this is it's going to give unpredictable results. So in general, don't use them. The other thing is fractional indexing doesn't work if you're trying to build an array. Remember, when you're addressing an array, it must be integers and positive integers greater than 0. Just like branching, we can in branching we can do a if statement within an if statement, or a if statement within a switch case statement, or vice versa. We can also do loops inside of loops. We can do for loops inside a while loop, a for loop inside a for loop. So here's kind of a classic example. I've got 2 layers of for loops, and what this will do is actually, and it's only doing it this way because that's the way I've set it up to do, but we might use it to build a matrix. So let's run this code, and I've put a breakpoint here so we can watch it run. So I'm going to run. And now you see what I did is I made an array, I made a variable called rows and a variable called columns, and they're 3 and 4, and it hasn't executed this first line of code. So I'm going to go ahead and step through. Now we see that row index is 1. That's because the code here is reading, this is a for loop. Row index will be my index that the for loop will index, and it's going to start at 1. The step value is going to be 1 since I haven't specified, and the end value is rows. In this case, that is 3. So it's going to make a row index, set it equal to 1. I'll step again, and now I'm inside my second for loop. And now I've got the index column index, and I'm starting at 1, and I'm ending at calls, which I set to 4. So now we can see here, row index is 1, column index is 1, and let's execute this next line of code. And what it's doing is putting 1, 1, and it's going to add 1 plus 1. So let's step there. And now I've made a matrix A. It's a 1 by 1. So it didn't exist before, and we're building it on the fly. So let's watch this thing go. And once I reach the first for loop's end, I don't get to go up to the top level. So what you'll notice here is that it'll keep stepping along the columns. So we're basically going to be building row 1 before we start row 2. So I step to the top. Now you look, our row index holds at 1, but now we're looping through our column index. So I have 1, 2. So in the 1, 2 entry, we should get 3. I'll step again. And in the index for column is now 3, so we should get 4. And now we remember columns is 4, so we'll step one more time. And there you have it, 5. Now when I do this next step, it terminated this interior for loop because 5 is greater than 4. Now it's going to go to the end of the first for loop, and it's going to say, are the row indexes, is that greater than the stop value, which is 3? Of course, that's not the case, so it's going to come back to the top. And now I'm going to start building column 2. So I'll just keep stepping through there. And we've built column 2. And we've got one more time through this loop because remember, we're having 3 rows. So right now the row index is 2. My column index is 4. I'll step through. Now you see that row index is 3, column index is still 4 because it hasn't been reset. Now when I come to the beginning of this for loop, it's going to reset column index to start from 1. So I'm going to step, and you'll see column index is 1. And now we're going to be building our third row of this matrix. And now we've finished, and we've built a matrix with a nested for loop. So that's a for loop within a for loop. Now that we're comfortable with making arrays, either 1 by 1 or 1 by n arrays, or as we saw in our previous example, a m by n array, so a matrix, I want to show you a sort of classic error when people do for loops. And let's just say the student wants to make the following array. Now, of course, we could do this with an implicit array, right, by doing 2 step by 2 to 8. So that's actually an implicit array. That would run a lot faster than my code, but I want to show how we could do that with a for loop. And so here's the student's code, and they say for I equals 1 to 4, x equals 2 times I, which of course, you know, 2 times 1 would give you 2, and so on, etc. So let's go and run through this code. So I'm going to go ahead and run, hit run. And now what we see is I'm at the beginning of the for loop. You know that because of this green arrow. I'll hit step, and I've created I, my index I, and I'll step again. And you see x is equal to 2. Now I'm at the end of the code, and I'll hit my step again. And x is equal to 4. And I hit my step again, and x is equal to 6, and x is equal to 8. What happened? Did I get the array that I wanted to? So let me type in x at the sort of end of this code. And it did not return the array I want. I have just a 1 by 1. And actually the problem here, and I see this all the time, is that you might forget to add your index into the array that you're trying to build. So if I'm trying to build up x, I need to add this index in there. So now let's run this again. I'm not going to step through it, but I'm just going to run this. And now you see that it built up that array x. And of course you could suppress this output, but I actually like it for this demonstration is that you see as it went through, it didn't override that previous address. So if you don't index the thing you're trying to build with your index for your for loop, then you're not going to actually build an array, you're just going to build a one by one. A common thing that people tend to do with for loops is to sum things up. So say I build some array x, and I want to add each element of x. What we could do is make a sort of counter, and let's start it at 0. So I'm initializing this sum x to be 0, and then I'm going to initialize my for loop. Index is actually the thing that I'll be indexing. I'm starting at 1, stepping by 1 to length of x, because I don't want to do the math here and count how long x is. And what I'm going to do is add sum to sum, and then so I'm setting it equal to itself. So the first time it's just going to be sum x. I'm going to reset it to be equal to 0 plus whatever the first element of x is. That's the first time through the loop, and that would be 3. And then the next time through the loop, it's going to add 3, so it'll say sum x is equal to 3 plus x of 2, which of course would be 6, so it should add 9. So let's go ahead and run this loop, and as a double check, I've actually just used MATLAB's internal function sum. So let's go ahead and run that. And we see here that it did faithfully execute the code as we had anticipated. Another question that comes up, and this is not so often, so this is sort of a rare occurrence, but maybe you would like to try to overwrite your for loop index. So remember, you're making this index. It actually is a variable that will show up in your workspace, and it does not get deleted. So what will happen when I execute this code? So I have for index, my start value is 1, my stop value is 4, and I'm stepping by 1. I'm going to go ahead and display that index to my command window, and then I'm going to make index equal to 1. So for the first time I'm running through this loop, sure, that doesn't do anything, but what will happen when it's 2? Am I just going to reset this back to 1 and then sort of get an infinite loop here where the index value is never greater than the end value or the stop value? And it turns out that it will not. MATLAB is actually running a function for, and it has its internal memory on what the index should be. And even if you try to force it to be something else, it will reset it. So let's watch this here. So now I'm going to start my for loop, and now I've created some variable index, and it's equal to 1. I'll display that to the screen. So now I have the 1 being displayed, and then I'm going to reassign it to 1. Okay, now I'm at the end of the loop. I'll go back up to the top and ask, is this index less than what we started at, right? Or so less than 4, which would be the, is this index greater than 4, which would make us terminate this for loop and move on with our code. So let's step again. And it's not, of course, so it went to display the index, and in this case, it'll display 2 because it's stepped. It's going to do our incrementing like it's been doing for us this entire time. But now I'm going to reset that index to 1. So you see here, index has a value of 1 because I forced it. It was 2, and I forced it back to 1. So what's going to happen here? So now I'm at the top of my for loop, and you see, regardless of me forcing it to being 1, MATLAB knew that it was 2, and it should go to the next step value, or it should increment by the next step value, which was 1, and go to 3. So I'll step it again, and I'm forcing index back to be 1. And in this case, what's going to happen? Well, it's going to force it back to 4. So MATLAB is sort of smarter than you. You can't break it. This is not going to make an infinite loop. Now we'll talk about infinite loops in a moment when we discuss while loops, and there you can get stuck. So that's kind of the nice thing about for loops, is it's actually quite difficult to convert them into an infinite loop. When running a for loop or even a while loop, a key safeguard is the break statement. And let's take a look at this code here, which you can run in MATLAB. And I have an array y, 1 by 1, and an array x, and my index is k, and I'm stepping to the length of x. And this is actually a classic thing to do where you might not know how long your array is, so you just, for the end statement, you just say whatever the length of the array you might want to manipulate. So here I said if k is less than 0, break. And what the break will do, it will exit out of the loop. So it'll jump all the way to the end of the loop. So it won't execute anymore. So this is actually a nice sort of safeguard, because you see here, I said x of k. So k would start at 1 and go to the length of x, which in this case is 1, 2, 3, 4, 5. And the second time through this loop, it would try to assign here. This is the code. So it's going to see this if statement. It's going to say if x of k is less than 0, break. So this first time, x of 1, because k is 1, which is not less than 0, so it will not get in here and go to this line of code and compute the square root. What we don't want to do, though, is compute the square root of a negative number. So in this case, it would execute this loop, and k would now be 2. And x of k is less than 0. We wouldn't want to compute that in our y array that we're building, so we're going to just break out of this loop. So that's a nice thing for you to use if applicable. But there's also another one where, say I wanted to compute the rest of the array, like this 2 here, it's bugging me. It's going to screw up my y array that I'm trying to build. But instead of escaping all the way through the loop, what you can do is just continue, and continue just skips the rest of the code within your for loop and goes back to the top. So it would just essentially skip that index. So the way that this would run is when it hits k, being 2, and it sees this -2, it would just say continue. So it would not execute this line of code. It would jump back to the top of the for loop. It would be stepping by 1, so now k would be 3. And this is not true, so it would do the computation for y. And then as we go along, now what we see here is I'm not building an array y, I'm actually recalculating it every single time. So this wouldn't give you an array. However, the nice thing is that I would skip the negative values in computing this square root of x of k. So the continue and break functions are very useful for for loops and while loops. Now that you're more familiar with for loops, go ahead and take this time to answer the following question. So I have an array cost. It's a 1 by 3, and I want to add up all the things in cost. And I want to achieve that with a for loop. So what is the proper way to initialize this code? So below here I have some choices for you, and what would be the correct initialization for line 3? And the correct initialization is for index 1, 2, so start at 1, step by 1, and to length of costs. And the reason why this first one didn't work is because I didn't use the right index. If you noticed here, a subtle thing is that down here, the index was index. So although this would loop through the entire length, it wouldn't assign it to anything. So here's a question. I have a function called movieOrg function, and what I want to take are 2 inputs where they're cell inputs. They're called movie titles and a Rotten Tomato score, and both of them should be m by 1. So these are m by 1 cells, and in each row of the cell, of course this is giving us, since m can be more than 1, it's going to be giving us a a column vector. But the rows of movie titles should be their movie titles, and those should correspond to those movies' Rotten Tomato scores. But what I want to do is organize that into another cell that's m by 2, where the first column is the movie titles, and then the second column would be the Rotten Tomato score. And I want to achieve that by doing a for loop. So go ahead and put in what the correct missing part of this initialization of my for loop would be. So my index is k, and I'm starting at 1, but what should be my step value, and what should be my end value? So go ahead and put in your title now, or put in your answer now. And you should be stepping by 1. If you did 1 semicolon, that's okay, that would be correct, but it should be length movie titles, because we don't know how long the movie titles is. So you shouldn't do a fixed value if you don't know how many movie titles your user is going to give your function. Well, what should I do here? So I'm going to be building up my movie score cell, and what should be the addressing for this? And of course, it's k, comma 1. That's because k will hold on the row, and I'm going to be put them in the first column. So I'm going to put the kth item of movie titles. And remember that since movie titles was a cell, I need to use the curly braces. If I use the smooth brackets, I would be, if I use the parentheses, so the smooth ones, I would be actually just putting a cell in my cell. I actually want to put the car array in my cell, so that's why I'm using the braces. What would I put for populating the Rotten Tomatoes score if I want to put it in the second column? Of course, k, my row, should stay the same, but now I am populating the second column, and I should put the kth Rotten Tomatoes score in there. So this code would build up a movie score cell without having to actually enter in each thing one by one when I'm doing this concatenation.